Hello everyone, I'm Bahador Bahmani. I'm a PhD student under supervision of Professor Wei Ching Sun at Columbia University. Basically, our contribution in this work can be summarized into three parts. First, we introduce a fully model-free formulation for poroelasticity problem. Second, we introduce two hybridized variants of that. And third, we introduce a fast nearest neighbor search based on the KD3 data structure to address the scalability issue of the original model-free framework. As you can imagine, the poroelasticity problem by its nature has multifidelity characteristics. For example, here you can see classical model can predict the solid related properties well, but in contrast, the error between the model and the data are considerable in the case of, for example, permeability prediction, even in log scale. That motivates us to introduce a hybrid framework that combines model-based approach and model-free approaches. What we mean by model-free, it means we relax the assumption about the constitutive laws, and we are interested in non-parametric data-driven algorithms that minimize the distance between the conservation law and the database. So as you can imagine, the most important ingredient in this method is the introduction of an appropriate norm for poroelastic phase space. This is the norm we define here. And for the hybrid formulation, we have more or less similar framework and structure, and you can find it in our paper. We solve this problem numerically by fixed point methods, which leads to a global and local minimization, the sub-problems. Unfortunately, the local minimization problem is an NP-hard problem, and its computational cost is super high. We introduce a KD3 data structure that can reduce the amount of calculation significantly. As you can see, it can reduce the 6-hour simulation to 4 minutes, which is 2 orders of magnitude faster. We verified our formulation against analytical solution, and you can see a good agreement between all of them. Also, we challenge our hybrid formulation with this difficult problem. Basically, we have a nonlinear hyperelastic form for solid behavior. We have a database for fluid part, and the porosity, and we have a heterogeneous porosity in the domain. Eventually, you can see the evolution of porosity permeability at a specific quadrature point, which is such a complex behavior which cannot be captured by classical framework. For example, here you can see from this point to this point, porosity is decreased, but permeability is increased. As a conclusion, we verified our formulation against analytical solution. We show the robustness of the formulation against nonlinearity and evolving heterogeneity, and we show that KD3 can reduce the computational time exponentially. We thank our sponsor. We thank you for attention. Please don't hesitate to contact me if you have any question, and my email is bb2969@columbia.edu. Thanks.